In this video, I am explaining the Fet Characterstics Experiment. So here we are using BFW10 Fet, whose configuration is, pin configuration is like when it is inserted on the breadboard with substrate facing us. At that moment, the pin configuration is left to right, gate, drain and source. So we insert the FET and then make the power supply connections. The channel 1 is for the gate supply, channel 2 is for the drain supply. Gate we give the negative voltage, drain we give the positive voltage. So starting with the gate voltage, we will keep it as 0 volts, and then the channel 2 drain voltage we slowly increase from 0 to 1 volt in intervals of 1 volt. So at 1 volt voltage, we have the current as 4.54 milliamperes. When we are increasing it to 2 volts, it is coming around 6.9. Similarly, for 3 volts, it is coming around 7.96. At 4 volts, it is coming down to 8.3. And for 5 volts, it is 8.4. For 6 volts, it is 8.5. For 7 volts, it is 8.5. And for 8 volts, 8.53. 9 volts, 8.54. 10 volts, 8.53 itself. So when we are reducing, so these are the readings which become constant after 6 volts or somewhere around. So this we can see from the graph. And then when for the next characteristic, we reduce the drain voltage to 0, and then the gate voltage we put it for minus 0.5 volts. Minus 0.5, right? Minus 0.5 volts. Right, minus 0.5051, we set it. And then now once again the drain voltage, when we are increasing to from 0 to 1, we can have the voltage as, we can have the current as 3.5 milliamperes. For 2 volts it is 5.4. For 3 volts it is 5.92. For 4 volts 6.14. For 5 volts 6.27, almost becoming constant. For 6 volts it is 6.34. For 7 volts it is 6.38. For 8 volts it is 6.42. For 9 volts it is 6.44. For 10 volts it is around 9.46. So these are I am reducing once again the drain voltage. Then we can draw these two characteristics for finding out the drain resistance VDS versus ID at constant VGS. Considering any of the curve, we can take a delta VDS and correspondingly delta IDS we can take it, find out, divide the delta VDS by delta ID gives us the drain resistance RD. Similarly, the second characteristic, transfer characteristic it is. So transfer characteristic, we keep the gate voltage as 0 and drain voltage as a constant voltage. So let me increase the drain voltage to somewhere around till it reaches some 6 milliamperes. 6 milliamperes. 5.996. So whatever be the voltage, I have kept gate voltage as 0. So there at that moment, the drain voltage, when it is varied to 1.6, it is giving 6 milliamperes. Now let me go to gate voltage, then increase in steps of 0.5. So at 0, it is 6 milliamperes. Now I am increasing to minus 0.5. minus 0.5. So at minus 0.5 it is 4.75 milliamperes. Similarly, when I am increasing to minus 1 volt, 1 volt it is, minus 1 gate voltage, the drain current reduces to 3.59 milliamperes. Similarly, when I increase to 1.5, right, 1.5 volts, when I am increasing it, then it is coming down to 1.5 volts, the gate to source voltage. At that moment it is 2.49 milliamperes. When it is increased to 2 volts, it is reduced to 1.41. Then when it is increased to 2.5, it has come down to 0.6. Now, when I am slowly increasing it, then it has to come down to 0. This I have to, for 3 volts, it is 0.09 and 0.09. So now I increase the voltage so that the current becomes 0. So this particular voltage, now it is 0.00. It is at 3.33 millivolt, 3.33 volts. So after 3, I haven't gone for 3.5, but I have slowly varied the voltage so that at 3.3 volts of gate source voltage, minus 3.33, the drain current has become 0. So this is the cutoff voltage which becomes equal to the pinch off voltage. This we have seen in case of characteristics. So the drain current, the cutoff voltage which is 3.33, we have to mark it and then draw the graph. These graphs are like the drain characteristic. When we are drawing for 0 volts it is 8 milliamperes, 8.4. For 1 volt it will be around 6.4 milliamperes. So only the shape I am talking about, whereas the transfer characteristic we can start from 4 or 6 milliamperes, whatever we have got, 6 milliamperes. Then from there onwards, when we are increasing the voltage, it has come down to 0. Right? At that moment, what is the voltage? The 3.3 volts we have to note down, and then at that moment it is the cutoff. So we have to find out the drain resistance, and from this it is GM value, mu conductance. So both these things if I multiply, then we get mu amplification factor. So the characteristics we have to write, we have to draw and then find out these parameters. From the drain characteristic it is drain resistance, from the transfer characteristic it is the conductance. Right? Thank you.